4 minutes. This is roughly where we got stuck last night at 4 minutes and 1 second exactly.
Yes, now we've passed the pressurization of the propellant tanks, so the filling process has been stopped.
We had a last-minute weather check at 10 minutes, didn't we, Alex? And they gave us a green for the weather?
Yes, we had a green already at when it's 20 minutes, and we'll have we had the last weather report at when it's 10 minutes, which was green as well.
It was raining earlier in the day, but you can see the sky has cleared considerably, and we should have fine weather for launch. We should have some fine pictures at liftoff on this very first launch of the year. Up at the Launch Control Center, what's going on?
The Launch Control Center is now under the heading of Klaus Zell, our launch operations manager. He's conducting the Ariane Space Launch Team and conducting the last operations and monitoring everything which is happening on the launch vehicle.
They monitor all the checks that take Ariane down to liftoff, not beyond. Is that right?
Yes, they monitor all what's happening on the launcher and all the information coming from the different checks.
Now, how many people are up there? I know there are 3 teams. How many people?
Around 150 people, maybe 200, including all the people in charge of the ground installations maintenance.
I think there are 3 teams basically up there, coordinating the campaign and the countdown, guaranteeing flight readiness.
Yeah, there may be even 2 teams preparing for 2 different launch campaigns, because we can prepare our launcher for the next flight, and while being about to finish the campaign of the previous one.
All that taking place about 14 kilometers away from here, where we are in Jupiter. You can see Ariane on the pad. Coming up on 2 minutes, we're still green. That's the color we want.
We're still green, which is very good news.
What's happening now?
Now, what's happening is that we have the very last operations on the launch vehicle, which will progressively become totally autonomous from the ground systems.
This is what basically happens during the synchronized sequence from the 7 minutes down to liftoff is power. Am I right in saying power passes from the ground control over to autonomous onboard computer control?
Absolutely.
Okay, so that is what's happening now. If we bring the camera back into Jupiter, you'll see people starting to wander out onto the terraces. There they are. They're going out. There are 2 terraces on either side of us here, observation decks, and the VIPs and invited guests go out there usually about this time, and they have a bird's eye view of the launcher lifting off, passing right over our heads on her way. The DDO will call out the 1-minute mark in just a moment, and we'll be into the final 60 seconds of Flight 200.
Attention pour H0 moins 1 minute. Top H0 moins 1 minute.
All right, we're into the final 60 seconds of the first launch of the year. Remember, you can follow all the action on the website. You have the address right there. The ignition sequence, tell us about that, Alex. You'll hear the DDO call out allumage,
yes,
which is ignition.
You'll see the flame under the main engine, Vulcan. So we shall ignite the engine and check it for 7 seconds.
That's the main engine.
That's the main engine, and when everything's fine and with the check is okay, then the ignition of the boosters and the actual liftoff.
Okay, so you get main engine lights up first, computers check out for 7 seconds, all the pressure, testing it on the ground, and then the boosters go. We'll let the DDO call out the final countdown and be back after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage Vulcain. Confirmé. Top, allumage EAP, décollage. Les paramètres à bord sont normaux.
Beautiful there. Ariane off on her way with just a 24-hour delay, leaving a trail of gold as she rises into the sky over French Guiana at 18:51 local time and right on time. Ariane began her mission.
And right on time. So we had a mass at liftoff of 773 tons, including 554 tons for the sole boosters. The boosters, which give a very strong initial acceleration that will increase velocity from 0 to 7,200 kilometers per hour in about 2.3 minutes. That's 4,500 miles per hour. So after booster separation, which will occur in about 2 minutes, the launcher will have lost about 75% of its liftoff mass. The boosters will fall down into the Atlantic Ocean in a zone which has been secured by an international advice to maritime navigation.
Ariane burning now 5 tons of fuel per second. That's 2.5 tons in each booster per second. The EPC, also the core stage, as it's called, is burning another 300 kilos of fuel per second. All that adds up to roughly the equivalent of a dozen Airbuses. She's now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see. 4 powered flight phases tonight. We're in the first one, the main engine and the boosters. And the boosters, as Alex said, they're going to burn for another maybe 20 seconds. Alex, take a look on the left, the upper left screen. Can you give us a description of the curve, please?
Yeah, we see the simulated flight trajectory, which is computed by using very accurate mathematical models of the launcher and the ATV, and by application, of course, of the Keplerian laws for the ballistic phase.
Which we're going to hear about a little later.
Yeah, a little later.
All 3 of them.
So the Mach, which follows...
DDO has just called out the separation of the boosters. You can see what that looks like. There's another one out of camera range on the left, but they fall back down right on time at about 64 kilometers up, I think. They fall away from the shore. People streaming back in from the terraces, you can see in the background there.
Yes, now to follow the actual flight. And now we're expecting the fairing separation.
That's the next milestone.
Minutes.
You can see the cursor crawling up on the upper left. I don't know if you can read it. Sep Quaff, it says separation of the fairing. On the lower left, Alex, can you describe what the bottom lines are?
Yes, we have the real-time information from the launcher of the velocity and the altitude, and also the angle of the telemetry antenna with respect to horizontal.
So you see the altitude. The altitude is 102 kilometers. That's the second line. So we're above the atmosphere, which is where we can separate the fairing, and the DDO will call out that milestone in a moment. We are in the second. There it is. Largage
there it is. So we don't need the protection of the fairing anymore. We have crossed the atmospheric layers, and then now we don't need this 2 tons weight anymore.
They're actually 2 halves, 1 half like one of the boosters before was out of
it's cut vertically and
range.
horizontally.
Everything is perfect on board, says the DDO. The ATV now under the fairing, exposed to the elements. And we're going to go now to the next part of the broadcast, which is the latest news from Arianespace, and there is a lot of it. So take a look. Ariane ended 2010 in style with its 6th successful launch on December 29th, delivering 2 telecommunication satellites, Hispasat-1E for Spain and KoreaSat-6 for South Korea. It was the 41st straight successful mission for the European launch vehicle. 2010 was a big year for Arianespace, with 12 contracts signed for Ariane and 7 for Soyuz. In all, 6 successful launches for a total of 12 satellites. 2011 promises to be as big, with Soyuz and Vega bringing their launch services to the space base. Tokyo, January 19th. During the EJBRT roundtable of Japanese and European industrialists, Jean-Yves Le Gall met with Japan's Prime Minister, Naoto Kan. The meeting underscored strengthening cooperation between Europe and Japan in matters of space research and in commercial space. Eutelsat has signed with Arianespace to launch one of its new satellites in 2012. This is the 26th contract between the 2 partners. Jean-Yves Le Gall and Dr. Volker Liebig of the European Space Agency also signed for launch of Sentinel-1A, an environmental monitoring satellite, for December of next year. Baikonur, January 28th. The Soyuz once again successfully lifted off from the Kazakhstan base. It was launch number 1,766 of the legendary vehicle. Meanwhile, here in French Guiana, Soyuz is preparing for her maiden voyage, set for the second half of this year. Work on the launch pad is nearly complete. Vega 2 is set for her first flight. Qualification tests continue here in French Guiana.
We're now in the stage of combined tests to be completed by the end of June. The mechanical tests are completed, the launcher module is now integrated into the Vega gantry, the electric tests are completed up to 50%. Now remain the fluid tests with the filling of the Avon, the fourth stage of Vega with its own propellants. Very delicate phase which will take place under the responsibility of Ariane Espace in French Guiana. During those next few months, the launch system review should also take place. The steering committee is planned for the end of June. The dates of the qualification flight campaign will then be known. It's planned for the early summer. The docking with the first Vega flight is planned for the autumn of this year. So let's keep our fingers crossed and good luck, Vega.
Ciao.
We are in the second of the powered flight phases. The main engine burning alone, it'll burn for between 8 and 9 minutes.
It will have burnt about 149 tons of liquid oxygen and 25 tons of hydrogen. And then let's learn more about the trajectory by Alexis Macaire.
Tonight's flight is using an Ariane 5 ES version. Storable propellant aboard the upper stage will allow it to reignite several times, something essential for placing ATV2 into its final orbit.
Unlike the other standard GTO flights carried out with an A5 ECA launcher with only one ignition of the upper stage, here with the ATV there will be two ignitions of the upper stage separated by a 45-minute-long ballistic phase. The first EPS boost will last 10 minutes. It is carried out above the Atlantic Ocean within reach of the Santa Maria station in the Azores. At the end of this EPS-1 boost, the launcher is already in a stable orbit with a perigee at 140 kilometers and an apogee at 260. This flight will go on above Europe, then Asia, until Australia. The EPS is ignited again. The EPS-2 boost will last 30 seconds and it will then reach the orbit targeted for this mission, 260 kilometer circular altitude. After the EPS-2 boost, the composite enters a stabilization phase.
This stabilization phase will let the ATV control center in Toulouse make contact with the ATV2. Then separation can occur. On its own, the ATV will circle the Earth for a week before catching up with the space station 22,000 kilometers ahead of it. It'll then have reached an altitude of 350 kilometers and be ready to dock.